anyway, we need to start looking in Lesson 4 of Unit 5. And for Lesson 4, we are going to concentrate on segment theorems. And the essential question given is, what is the relationship of the segments formed by intersecting chords, secants, tangents? And our vocabulary looks at similar triangles and angle-angle similarity theorem. So, you should have in front of you a worksheet. The worksheet is numbered 5.4.1. And you have the essential question, what relationship exists among segments of two intersecting chords in a circle? If two chords intersect in the interior of a circle, the blank of the lengths of the segments of one chord equals the blank of the lengths of the segments of the other chord. Alright, so we do have two chords in the interior of this circle. One of the chords is segment AB, and the other chord is segment CD. And so, let's try this once again. If two chords intersect, yes. In the interior of a circle, yes. The blank, the products. Listen in. The products of the lengths of the segments of one chord. So we're looking at one chord, segment AB. This chord is divided into two segments, smaller segments. One of those segments is segment AE, and the other is segment EB. So we want to find the product of those two segments. So we multiply this measure times this measure, as you can see here on your worksheet. Okay, and we want to set this equal to the products of the lengths of the segments of the other chord. So we have another chord, segment CD, and it is divided into two smaller segments. And we want to find the product for those two lengths. So we multiply the measure for segment CE times the measure of segment ED. Alright, so let's do a few practice problems, and then we can try a few of these on the back. For practice problem number 1, we want to set up an equation. And once again, we write an equation based on the relationships of the objects we're working with. In the past, when you saw a circle that had two intersecting chords, we were dealing with angles measures. And for an angle that is formed on the inside of a circle, that angle measure would equal to the measure of its arc plus the measure of its vertical angle arc divided by 2. But today we're dealing with the lengths of segments. So we focus on one chord. I like to begin with the one that has the variable involved. So we're looking at this segment here. So we want to set up a multiplication problem with this one chord. We need to multiply the length of this part, 4, times the length of this part, x. Let's write this on our paper and set that product equal to, and we want to go to the other chord and multiply this part of it, this length, 7 times the other part, 16. So we have our equation. Now we can solve for x. So take your calculator and let's complete this equation. On the left, 4 times x is 4x. On the right, we want to multiply 7 times 16, and we get a product of 112. Then we need to divide each side by 4 to isolate the x. So 112 divided by 4 give us 28. And just to make sure that this makes sense, we want to go back to the original equation and plug in 28 for x, and we should get equal amounts on both sides. Alright, so let's try the second problem. For the second problem, one rule of thumb is anytime you have an expression like x plus 6, I always advise you to go ahead and place parentheses around those expressions, okay? Now let's set up our equation. So let's focus on one of these chords. Let's take this one here. Alright, so we want to set up a multiplication problem. We want to multiply this part 9 times the other part of that chord times x plus 4. Remember to include parentheses. And then we set this product equal to, and we focus on the other chord. And we want to multiply this part of it 6 times the other part, x plus 6. We have our equation set up, so all we need to do now is simplify it. Alright, so we need to distribute 9 with the expression inside the parentheses. 9 times x, 9x, plus 9 times 4, 36. On the other side, let's do the same thing. 6 times x, 6x, plus 6 times 6 is 36. Now, when I see something like this, I prefer to deal with the variable terms first. So we want to move 6x. To undo 6x, we want to subtract 6x from both sides of the equation. That leaves 3x plus 36, and set that equal to 36 on the right. And then we're going to move 36 to the other side by subtracting 36 from both sides of the equation. That leaves 3 times x is equal to 0. And if we divide each side by 3, we find that x is 0. Okay. Let's substitute this back in and see it doesn't make sense. All right, we go back, we want to check. All right, come back up here. We have, I'll go back to the original. 9 times 0 plus 4, and set that product equal to 6 times 0 plus 6. So that would give me 9 times 4 is equal to 6 times 6. And 36 is equal to 36, so it does check. I'll pause for a moment and let you guys try problem 3.